Good. We'll just give everyone a few minutes to jump in. That should be all good. Let's get the chat open. 1, 2, testing. Can everyone hear me okay? Am I crunchy like last week or am I smooth? Testing. Smooth. Yay, that's how we like it.
Testing here. Am I also audible?
Is Joshua smooth? Yes. Yeah, it's interesting. It's so easy to get a sampling rate mismatch between these, applications we use to pipe stuff in and out of Discord. Okay, looking like a pretty awesome turnout here. Hello, folks. Good morning, good afternoon, good evening. It's great to have you back for another focused Max 9 office hours. Our topics of discussion today are the new JavaScript V8 engine and also Codebox. And we also have a bit of a special guest if you take a little bit of a peek up there in the right-hand corner. Our very own Dude 837 Sam Tarakajan is dropping in for today. The nature of these Max 9 focused office hours is that we run them a little differently. Usually we wait for questions till the end, but I'm sure as we're going along, you'll have questions. I'll try and keep tabs on those questions, and if they're relevant, I'll interrupt Joshua or Sam, and we can kind of answer them in the moment. Super excited to have Joshua here. Joshua is CTO, head of engineering at Cycling 74, and he's going to kick it off. Joshua, welcome to Discord Office Hours.
Cool. Thanks, Tom. And thanks everybody for showing up. So yeah, we did a ton of work for Max 9, and most of you have probably already been playing around with a little bit. And what I'm going to share today is just some context for V8 and Codebox, some of the work I was involved in. And yeah, let me try to share my screen and get into it. Okay. Is my screen coming through?
Yes.
Oh, I didn't share it with audio, just in case I get some audio. Let me start again. This is classic. Share sound. Oh, it was sharing. Okay, great. All right, so as you know, we've had JavaScript in Max for quite some time. The JavaScript engine that we had was a legacy Mozilla engine, which was tied to JavaScript 1.8.5. And this is, like 13 years old and focused on ECMAScript 5, which is a pretty old standard for web pages. And we spent a big effort updating our code to have a modern JavaScript engine. V8 supports ECMAScript 6. I need to move these like little overlays so I can access my patch. Inside ES6, there's a whole new set of things that you can do. You can use arrow functions right here, for example. You can use arrow functions, you can use spread operators where you take an array and it unfolds it as a serial list of arguments, for example. Multi-line text with replacement can be done. Let's see that here, spread. You can define classes for doing object-oriented programming. You can use typed arrays. Typed arrays have specific data types, and those I'm going to get into later. There's some interesting things that we can do for processing jitter matrices with typed arrays, default arguments to your functions, etc. So this new engine is the V8 engine, which is what's run inside Chrome and Node.js. The version that we're using is a little bit older than what's in the latest Node and the latest Chrome, but it's got complete support for ES 2022. So all the features of ES 2022 and a couple features of ES 2023. If you want to look at these kinds of things, the features of the different language iterations, you can see those at this link here. So not going to go too deep into those, but so basically the V8 object is a replacement for the JS object. We had to keep the JS object around so that we don't break old patches. There's a certain number of things that are impossible to do, and we still have a little bit of work left in order to fully support the objects that are available inside the JS object. And I'll cover a little bit more of that later. In addition to gaining more language features, we'll see that it can be a lot faster. Here we have some code that just iterates across an array, creating a sum. And we'll see that this takes about 125 milliseconds in the older JS engine, and it takes about 5 milliseconds. So we're seeing, a 25 times speed up in the newer engine for certain key math operations. Another fun thing, instead of having to have a patch as a separate file, you can now embed that directly in the patcher document. There's no file on disk here. If you don't have a file name argument, that's by default. We have this new Codebox object, which also embeds its code in the patcher. The Codebox objects are really handy, especially for quick prototyping where you don't have to switch back and forth between your text file or for illustration purposes in your patch, so you can see right at the top level what's going on. So those are some fun things. We have some new features available to JavaScript, for example, for attributes, and some of this was done to support parameter connect, but also to allow you to have nice displays with Attr UI. For your attribute, you can provide it with essentially a dictionary of key value pairs. So here, the fluffy, we can show that this attribute gets an on-off checkbox. Embed 1 means we save it in the patcher, and we can give it a label of here, enable fluffiness. I think if we go to our inspector, we'll see enable fluffiness here in the inspector. And some of this stuff is been put to use for the JitFX objects as well, which is something we can talk about a little bit later, but not sure exactly what more to say here, but you can set ranges, which is necessary for parameter connect. I can just do the parameter connect thing now. So here I can say connect, and I don't know, let's do it to something that has Boppy, has a nice range. So here, and we see that Boppy is getting updated while I change that. Dictionaries, there's some new utilities for being able to use dictionaries inside V8. I'm just doing this here in Codebox because it shows it in the patch nice and clearly. In the past, you could create a dictionary method, which would get called with the name of the dictionary. You would then have to create a new dictionary. You could do some things with that. Some things were harder than others, and then output a new dictionary's name. you can see that the output here on both sides is the same. This essentially.
Joshua, sorry to interrupt.
Oh yeah.
People asking if we could get the zoom in to 125 or 150 to see the text a little clearer.
Okay.
Thanks.
Yeah, this is gonna be hard to zoom around because both
I know it's a
Codebox and things.
it's a bit tricky, but
So yeah,
thank you.
sure. Yeah. So here, for example, the dictionary method is called with the name, and we would create a new dictionary, set some parameters on it, set some keys, copy from one to the other, set a new key, output this new dictionary's name. Now, what we can do is have a message dictionary method, and it actually converts it to a native JavaScript object. And so you can access it without get and set methods, and you can just output that same JavaScript object as a dictionary. And so this is a convenience function, and it actually makes working with large dictionaries with nested keys and other situations that are otherwise a real pain, and in some instances not even fully possible to work with just the get and set API for dictionaries. So arrays. Actually, in the old JavaScript object, you couldn't do this. You would actually have to make a special method and send the array name to JavaScript in order to do this. But this would be how you could do a similar thing for arrays in Max as you would do for dictionaries. On the left-hand side, where you create a new Max array, you give it a name, then you can access it with the Max array API in JavaScript. In the new engine, we can just pass in a Max array. It gets converted to a JavaScript array, and we can use all our ordinary JavaScript methods like push, pop, access it with indices, etc., and then output that array, and it'll send out. Let me actually just do this here. It sends out an array object, and here is an example. Here's with a flat array. Sends the 1, 2, 3, 4, and then this adds 5 to the end of it. And here you can do nested arrays of arrays. And we'll see that we post in, this doesn't get zoomed in, but here, let me clear this. We can see that we're appending arrays of arrays here, which are really cumbersome to work with using the old, using the Max array API, much easier to use inside JavaScript with native JavaScript arrays. Another data structure feature is the ability to access matrices. In the past, and I can't zoom in on this stuff easy. In the past, you would have to get an element or set an element individually inside the matrix. So this one walks through, and we're gonna set some values in a matrix by calling setCell. And how long did that take? It took about 600 milliseconds. Our new one, what we can do is we can actually use those typed arrays that I was talking about earlier, and we can set the whole matrix to that array. Basically, we have to do it. We can't easily use multi-dimensional arrays. It has to be a flattened array that is, all the planes, all the dimensions of the matrix, and but then you can copy that whole array into the matrix, or vice versa, copy it back. And how long does that take to do? It takes about 13 milliseconds the first time. Eventually, the JIT compiler will progressively get more and more optimized until a point for running some of this JavaScript code, especially things with tight loops. So anyways, that's like a 60x speed up we see there. And you can even do things like process, this is 1280 by 960 video that we're processing inside JavaScript at 90 frames a second, which is pretty cool. So here we're just inverting our image, but let's say we want to leave the red channel as is, but invert the green channel and blue channel. So for example, cool. So that's the basics about the V8 object. There's some differences between V8 and JS. We don't support native C, C++ JavaScript extensions. You know, certain packages like Mubu and other people, the Py.js work, use these native JavaScript extensions to interface with the legacy Mozilla API. That's not possible currently. You can build native classes that work with JavaScript, and that's how we've done most of the new API that's available, and how we wrap jitter objects and all sorts of things like that. And there's an example in the SDK. I don't have a link to it right now. Another JavaScript extension consideration is that we don't share a global context across all the different objects. So there's a few different things that that allowed us to do. We had this JS extensions folder, which would load JS extensions into the global context, and you could use things there. It's not possible. So if you do want to use those files, you'll want to use the include function to include that file inside your context. For the same reason, we also don't have shared global properties. Some people would, if you define a variable without the var keyword in JS, it will assign that property to the global instance that's shared across all JS objects. That's not possible. We can't share JavaScript object pointers across JS instances. You should serialize those as dictionaries to pass between objects. And there's no explicit garbage collection. Some people would use that for managing, you know, jitter arrays of jitter objects. That isn't available in the V8 engine. So you'll have to use FreePeer if you want to explicitly manage your memory. A couple things aren't supported listed here, but we're working on getting those things working bit by bit. And then we have the V8 UI object, which is very similar to the JS UI object. There's not too many differences, except for you can actually use ECMAScript 6. One of the things that's available with the V8 UI object that isn't available for JavaScript, for JS UI, is that it supports new pointer event style events. So you can get a little bit more information than the old Max style of handling mouse events. I'll share these patches later. This is in the help file, so if you want to go and dig in deeper, you can go and find out more about it. But the really exciting piece of this is for people that are on Windows, and I'm not on Windows right now. You can use pen tablets, and you can get tilt and pressure information here. That isn't supported on OS X. And multi-touch. So if you have a tablet like a Surface Pro or something like that, you can use multi-touch inside a single V8 UI object and across multiple ones. So it's pretty cool. So you can get a Mira-like setup going with V8 UI on your Windows tablets. Okay. On the matrix front, I made this little example yesterday. which what it does is we grab, here we're declaring some attributes. Kind of an interesting side topic. You need to, despite supporting modern JS, the let keyword and the const keyword have special meanings within JavaScript, and they don't get added as properties to the object. They're values within the lexical scope, which means like if you evaluate some code with that, you can make use of it, but you can't access it from the outside at a property. If we wanted to support that, we would actually have to, every time you tried to set this attribute alpha, we would have to evaluate a JavaScript string that we created, and it wouldn't be efficient. But so these attributes need to be defined with var. Similarly with functions, if you want arrow functions, some people like to use const, the name, arrow function. That won't show up as a method on your object. You're going to need to use var there, or this dot the name, in order to assign it to your object. So we have some attributes for the algorithm here. We receive a JIT matrix, and what we do when we get a jitter matrix is we copy those to a sparser matrix of particles, and then we're going to render those particles and have them slide back to their original coordinates. Let me just play with this. So this uses mouse events to create a radial displacement, and then some parameters here for a slide amount, how fast it slides back, the strength of the displacement, how long it takes to slide, etc. The resolution of the grid, the size of these points, an alpha amount, etc. So just a simple example of how to access the matrix, render values with those points that you grab from the matrix, and create a very simple sort of like spring back to original position particle system here. Again, we're working with data buffers, like a flat one-dimensional array for our pixels and our particles. And so I'll upload this and you can download and play with this code. If you get into it, you'll notice that you need to keep track of how that data is laid out. I found an interesting library that I'd like to explore, seeing how easy it is to use. I think it's called NDArray, and it's a JavaScript module for easily accessing multi-dimensional arrays on top of flat typed arrays like this. But I have not explored that yet. Okay, one of the coolest things about supporting a newer engine is that you can use all sorts of libraries that are out there. Actually, Numeric JS is ECMAScript 5 compatible, I believe, but there were some issues with the required implementation of the JavaScript object that made it hard to. Were you going to say something, Tom?
No.
Made it hard to make use of them. This one, if we look online, the Numeric library is a numeric computing JavaScript library, and you can do things like vector multiplication, dot products, calculate the inverse of a matrix. So this very simple little example, you can include this file, and then you can use the numeric library to take the dot product here, calculate the inverse of the matrix, and I think here I have it pretty printing like our matrix here, our vector, the dot product of the matrix and the vector. So possible to use a whole bunch of really cool libraries. Sam's going to show a really cool example of using this anime.js library that's out there in the wild, which was interesting to try to see what is all necessary to support them. He had to make a bunch of polyfills, which is a mock working example of things that are available in other systems like the web browser. So we also made available several different Codebox objects. So here is a node.codebox. So this is a simple example showing how to make a web server in Node.js. And here, JWeb, we're querying it. So one thing this lets you do is you can find out the time. The other cool thing that this shows is that it lets you grab a named dictionary. So what this does is it parses a request string. Here I'm going to request a URL with dict/fluffy, and the node.codebox is going to query the dictionary fluffy here, and then it's going to stringify that and write it back out the request response channel. So here, fluffy. Oh no, didn't work. Oh, I think it thought I edited, and yeah, there we go. So here's this dictionary we see down below. That's the dict.codebox, so you can display and edit dictionaries in a code box. So you could use this for remote monitoring of your patches, serving information to web APIs, etc. This is just a web server. And you see that this gets updated. There's, I think, 10 different Codebox objects, including the full family of gen, which if I turn this up, we can edit gen in the Codebox, dictionaries, call objects, I hadn't shown that one, jitter gen and pix. So etc. So everything that you could do already inside these different gen variants, but you can bring them to the top level, which is oftentimes more convenient in certain instances when you're moving really fast, or if you want to teach. It's great for teaching and illustrating things to have the Codebox in the top level. And that's the first section of stuff that I have to share, and I want to turn it over to Sam to talk about Anime JS and the work that he did on making a polyfill for it.
Cool. Thanks, Joshua. There's like a lot of cool stuff in there that I didn't know about, and it's pretty cool to see start to finish all that, all the work that went into V8. So like Joshua said, I was really interested to explore some of the stuff that you could do when you, hold on, I'm just sharing my screen. Hold one moment. Screen is shared. Excellent. I wanted to explore some of the stuff that you could do with the new V8 support, and in particular, whether there's some libraries that we could use to do some interesting stuff. So this Anime JS library is used for doing simple animations in the browser. You can do all kinds of stuff. Animating CSS parameters, animating, various parts of your web page, and there's lots of support for all the kinds of stuff that you would expect. Like, let's see, if I can find a good example of wanted to look for the easing properties in here.
It's
So all
down
the,
at the end of the, oh, there it is.
oh no, I think you're right. This is what I was actually looking for. So there's support for all different kinds of easing functions, and there's support for cool SVG animations. And as you can kind of see, maybe if I zoom a little bit, as you can kind of see, like the syntax for doing this kind of thing is pretty straightforward. And there's some kind of powerful stuff that you can do. And I'll show you some examples of how that works in Max. But the interesting thing is that if you look kind of at the very basics of how this library works, you just kind of create these little anime objects. And one of the properties here is the targets. And in the context of the web browser, these are CSS selectors. So they're strings that are going to identify the DOM elements in your web page that you're going to want to animate. But you can also just directly animate the properties of JavaScript objects. So here, there's some kind of battery object, and you identify that object as the target, and then you can actually animate different properties of that object. And if I click this, you see it's animating up these string values that are properties of this object. So this is the interesting thing, because this is something that we could use in Max. We could drive animations in Max and then use this library to get all the fun stuff. Like I'll show too that beyond even just the easing functions and the nice syntax, there's a bunch of other stuff too that's quite nice. So the only trick to doing this, if we jump into Max now and kind of look at how these things go, maybe first I'll just show some of the things that you can do. So here's that same battery. Let me know, by the way, if you can't, I'll jump in quickly. Let me know, somebody, if you can't, or Tom, maybe let me know if people are saying they can't see this. But here's that battery example. You can see this anime library. I can animate that text and also the color. And there's some nice stuff too, like you can combine different animations. So here's, this is just, randomly jumping from one place to another with a spring animation on the position. And then we're also animating the transform or the stretch on this ellipse to give a kind of darting around sort of effect. And there's other kind of cool support too. So for example, keyframes have support. You can make multi-part animations that have different sort of stages like this. And last but not least, there's a lot of support for animations that go kind of different values across all the structures that you're animating. So say you're animating a bunch of different repeating units, you can apply some different property to each one and get these kind of like cool staggered animations across all those things. So just to look quickly kind of at how this stuff would work, if we look at one of these files, let's look at maybe the simplest one, which is this, this demo for the charging battery. Let's see, we don't need this, do we? So it should look pretty similar to if you've done any custom drawing using mgraphics before. There's just some kind of paint function and your basic mgraphics setup. This is the polyfill that Joshua was talking about before. There's a few structures that anime expects to be defined because it's supposed to work in the context of a DOM, in the context of a web browser. So it expects there to be defined things like a node list, HTML collection, SVG elements. These are just things that in the context of the anime code, it's going to be doing things like asking, is there an SVG? Is this thing you've asked me to operate on an SVG element or not? Is it a node list or not? So in order to do what we are doing, which is just animating the properties of JavaScript objects, we don't really care so much about these things, what they actually are. And in fact, if you look at the definitions of these things in the polyfill, you'll see, for example, that node list is defined as an empty object, SVG element is an empty object, HTML is an empty object. We don't need them, but anime needs to know that they exist in some form in order to actually work. The interesting one kind of is the polyfill for request animation frame, a JavaScript function that gives you a callback whenever the browser is ready to draw the next frame. Obviously, that doesn't quite exist in Max in a one-to-one mapping. one-to-one correspondence, but we do have this paint function, and we do have a task object that we can use to schedule functions. And the polyfill uses those together to do something that's kind of like a request animation, or gives anime JS something like a request animation frame function. And then the way that this actually works is, so there's that polyfill you'd have to require. You acquire anime, you define the structure that you like, you set up your animations. The one thing about doing this in mgraphics, or doing it with mgraphics, I should say, and in V8, is you do have to tick the call this tick function on all your animations explicitly in your paint function. This is, you can do it without this, but this is how you get the smoothest animations, by synchronizing Max's redraw with the actual animation update. So that's all the kind of boilerplate you have to put in place. And then this is the kind of cool stuff you get to do. So you can animate any of these properties really easily. So for example, this right now, it's taking a second and there's a linear easing, but we could say, let's make it take half a second. Instead of animating to green, let's animate right the way through to blue. And instead of rounding to 1 decimal place, let's round to 2 decimal places. And then this should well, I've warped something with the way that it translates the color. The color is not what I expected, but you can see the extra decimal place. I have had some, it has been a bit of a grind to get the colors to quite, anime is animating color strings as they would appear in a web browser, and Max works with colors slightly differently. So it can take a little bit of work to get that to work. But now so since this is kind of the idea, that you set up animations just like this and then tick them, I can show you kind of some of the things you could play with in the context maybe of a staggering animation like this. So if we look at that file, this stagger.js, we can find where the actual animations are defined, and it's right here. So there's a ton of stuff you could play with and a lot of possibilities for customization. So for example, there's an easing function here. And right now we're using ease in out quad, quadratic easing on the animation curve. This is, I mean, in case you're not familiar, if you didn't do any kind of easing and you just used linear easing, the animation still works, but it looks kind of lifeless. It's just kind of going without any curving at all from the beginning to the end. There's a bunch of fun animations, for example, ease in, out, bounce, or maybe ease, let's do ease, out, bounce. And we can see what that looks like. A little bit of a jiggle there, I guess, making it look kind of liquidy. We could play with, so one of the cool things is I'm just applying the delay that's being applied here. So the delay that's being applied is using this anime stagger function to make the delay on each animation activating for each cell of this grid a function of where it is in the grid. And that's why it has this kind of circular shape to it, because the animation is starting sooner for objects at the center of the grid. But we don't have to do the delay this way. We could instead use a different custom delay function and say, let's delay more for elements that come later in this grid. And then once it reloads, after I save this document, you can see what that looks like. It's a little subtle because the animation is not that, the delay is not that long. But if we did this, say this might work. It's actually too long and now it's getting stuck, but let's take a look at this. Yeah, you can see it kind of starts at one point and goes to the end. And we can do the same thing with the color, for example. So instead of having just one color, we can make the color a function of where the element is in the grid. And that gives you this nice rainbow kind of thing. This delay is too short and it's warping up the demo. It's still too short and it's still warping up the demo. So I'll go back to this delay. Yeah, so you can see you can get these nice kind of things going with the color as well. And we could do the same thing with the rotation. Instead of just applying a random rotation, we could apply a rotation that's a function of the position in the array and get after I save this, get, yeah, these nice looking kind of animations. So there's a lot of cool stuff you can do with anime. I haven't whipped this all up into an example that you can just use yet. But soon this will go up on the Max examples as an example, with a bunch of assets that you could download and use. And if you are doing custom drawing using mgraphics and the V8 UI object, then you could also take advantage of this kind of cool syntax for defining animations to build whatever kind of custom thing you want to build. So yeah, that's kind of how to use anime with V8. And unless there's anything people want to know, I'll just pass it back over to Joshua.
Nice.
Cool. Thanks, Sam. That's awesome work.
There's a question here from Quail. How is the frame rate with these animations, by the way? Is this still done in low priority thread rate?
Yeah, all drawing in V8 UI is in the low priority thread, and all execution actually.
Yeah, there's a very good question here from Stephen Meyer. JS strategy in general in Max and Max for Live specifically, are there recommended strategies for organizing JS code in terms of the number of V8 instances? For example, I have an algorithm that generates note data that could be written into live clips using the live object model. Does it matter whether I have a single V8 instance somewhere in the live set versus having an instance per live track? So is this a question about any impact on having many V8 object instances or just one?
It will use more resources. Every instance of V8 is going to have overhead. I don't know what the size of that overhead is, so I would just recommend doing some empirical analysis of what you're working on. I personally wouldn't worry about it until it becomes a problem. So, but in general, we're finding using tons of V8 instances works well. Let me go back to sharing my screen, and I can highlight that for a lot of the effects objects, for example, all of these are, not all of, certain ones are V8 instances. And so I don't know if you've seen these like mega patches for JIT effects, but they have, like tons of V8 instances. And so I wouldn't worry too bad about having lots of V8 instances. But if you are experiencing issues and you need to make sure that you use as little RAM as possible, you might find that managing them centrally, like you suggest, is okay or desired.
Nice. Also, just a prompt, Sam and Joshua, if you guys can post patches in the
Oh, we will.
comments for folks, yep, that would be appreciated. Another question here, is it possible to use breakpoints in code while debugging JavaScript with the new V8 engine? If not, is it planned?
It's not possible right now, and it's not planned. It would be very cool to support. You can do that with Node inside Max, and that's because Node has put a lot of work into building this inspect API in place that you can attach with Chrome as a debugger. We could do that. It would be like tons and tons and tons of work. So I don't expect that happening anytime soon. I would love to do it, and I would love to implement a whole lot of other things first. It kind of brings the question of like future work, some stuff that I wrote down. First off, we want to make sure that we get all the existing JavaScript classes that we can present in V8. I'd love to implement ESM, which is ECMAScript modules. The modules that we support right now are common JS format modules, so that would be cool. Again, the engine itself doesn't provide that. you need to implement, any host needs to implement the module support. And so, Node has implemented their module support, Chrome has implemented their module support. We could learn from those to do something similar, but it has to be built on top of the V8 engine. I've been piddling away a little bit at WASM support, and I have like very rudimentary stuff working, but most complex WASM libraries need a whole lot of additional infrastructure that we don't have, that kind of ties into this web standard API and some of the stuff that Sam had to do polyfills for. So would like to support WASM inside V8. I would also like to explore some threading possibilities. A lot of people are excited about running it in high priority, and we have done experiments. The biggest problem there is we don't want to, in scheduler and audio interrupt, it's not deterministic exactly how long garbage collection could happen, so you'll have audio dropouts. So I'm more inclined to get things working, if in high priority, only if scheduler and audio interrupt is not on. Excuse me. Also, we have to figure out a way to sandbox stuff that's not safe to do. So you'd probably have a much more restricted set of JavaScript APIs, similar to building workers in web workers, or Node has worker API as well. So for doing multi-threading, so that stuff would be interesting to explore. Some of these other web standard APIs like fetch, sockets, etc. There's a whole bunch of that stuff talked on this Winter CG site that I linked to in the patch. But yeah, so getting it working with source level debugging is not on a near-term roadmap, and even a lot of this future work, it's not necessarily going to happen anytime soon. We're going to chip away at stuff over time. But
Any plans to support TypeScript in the future?
not directly. You can pretty easily run a TypeScript to ES6 converter. There are some things that just do stripping of type information and templates and stuff like that. We could explore that, but otherwise I would recommend, if you're going to use TypeScript, that you compile it to ECMAScript 6 via TSC, and then you can run it inside Max.
Nice. Folks, we've probably got Sam and Joshua here for another 10 minutes or so. We'll go to the top of the hour. If you have more questions, drop them in the chat. It's a great time to get an immediate answer.
Another thing on the type information, we have been working on creating type defs for use inside text editors. We have this on Macintosh. We have this experimental Monaco text editor. So what this does is, it basically is a version of VS Code, but Monaco, the web kind of open version of VS Code. And what we can do here is, it has auto completion and some type information about things. So here, mgraphics, we can see is there. And then this is really helpful, if you're trying to learn or remember what all the mgraphics functions are. Say set matrix, and it has inline documentation on this stuff, as well as type information. So Sam and Isabel have been working on this set of type defs for the Max API, and we're going to be improving that over time. Sadly, trying to build for the Codebox a complete autocomplete system like this, or trying to get the web browser-based version running inside the patcher for so many instances of Codebox seems prohibitive. So it's not gonna happen there in the immediate future. But this is a nice way to learn by using this experimental Monaco editor, and I think the plan, Sam, is that we want to make that available publicly as well, so people can install it for common type defs inside, standalone VS Code or other type def compatible editors. Well, I can't see the chat if you're writing it.
Yes, I don't know what specifically would. I think just yes is the answer to that. Yeah.
Cool. There's a whole bunch of really cool stuff. As I mentioned in the JitFX, if you're getting deep into JavaScript, I would encourage looking at some of these JitFX examples. Also, the JIT geometry tutorials have a lot of great examples talking about how to work with the geometry inside JavaScript. I'm not going to cover all the details of that. It's out of scope, but I just want to pass pointers of things for people to look into. There's some really cool tutorials that Matteo made. These are all linked to in that patch. This one's really amazing and freaky. The JIT UI objects, these are good examples of looking at an include-based strategy. Include, unlike require, includes that JavaScript at the top level of your patch. So certain things that you don't want encapsulated inside a module, but you want it included at the top level, you can use that. Similar to including multiple source definitions in a web page. We had some guests, Rainbow Circuit and Esteban and S and another person. Ringtone Tools make some really cool examples using V8 UI and JS UI. I highly recommend going to this article and downloading and playing with their examples. Thank you all, those of you who might be here that worked on that. Really cool stuff. Our dear friend Darwin, a long time ago, made really great mgraphics patch a day examples. And this article from 2011 still is going to be useful for trying things out inside V8 UI. Highly recommend going through, and there's just tons of great information here. For learning more about ES6, there's some of these resources that I'll point people to. This has lots of clear examples of all these really neat aspects of ECMAScript 6. Some of the things I haven't even played with yet, for example, like generators. These are pretty cool, where you can define a special kind of iterator, or just a function that then will yield, and other things can happen independently, and then it can restart. So I haven't played with that stuff, but there's some neat things here, and these sites that are linked to in the patch I'll upload are great places to explore more about ES6. There's a really extensive book here that's available for free online, and yeah, I think that's everything I put together.
Nice. Sam, anything else from Sam?
There's a question here about when to use V8 and when to use Node that I can talk about quickly. It's just to say that I would say if you don't know, probably you want to use V8. The major difference is that V8 is running inside of Max and knows about the objects that are in the patch. If you're trying to do something like custom drawing, scripting the behavior of a patch, using information about the state of objects and connections to make some kind of decision, you want to use V8. And for most applications, V8 will do the work for you. You want to lean out and use Node script when you do want to run a separate process that you need the features of Node to do. Some of the things that Node is really good at is interacting with your file system or interacting with remote resources. If you're doing things like making a patch that's going to be making API requests sending requests up to, generate, like I've seen some projects that use Node scripts to make remote requests, to have some kind of images be generated, download those, and then load them up into the patch. These are the kind of things that Node script is really good for. So that's I would say the basic breakdown when to use each one.
Awesome. Folks, we've probably got a couple of minutes left. Any last minute questions? Otherwise, we might wrap it up for the day. Huge thanks for coming along, Sam and Joshua. It's really great to get this information in real time. I think the whole community's pretty happy to receive it. And we've had a solid crew of people here the whole time. Folks, Joshua and Sam have posted their patches in the comments. They'll be available later along with the YouTube video, or you can grab them now. This stream will be up later today. We have another Max 9 focused office hours next week. David Zaccarelli, Cycling 74 CEO. He will be along to talk about Max 9 updates in general, as well as the new Param Connect feature that's in Max 9. And I'm sure David will have some extra special stuff for us as well. Some goodies. Awesome.
Cool. There was one question about when to use JWeb, and for that one, if Sam didn't mention, I couldn't tell. I was paying attention to too many different things. But JWeb, if you want to render web pages or make use of web code, JWeb is the way to go. It executes out of process similar to Node, and but you have the full features of a web browser there. So some of this stuff that Sam's been showing with Anime.js or other libraries could be much easier, or do take advantage of the tools that are available inside the web browser, and you should use that. It is also heavyweight though. It creates a whole separate process, and if we're talking about resources and performance and things like that, that was brought up earlier, I wouldn't probably use tons of different JWeb instances inside of a single patch. I would, use one JWeb instance and have lots of components within a single page.
Nice. Awesome. Thanks, Joshua.
Cool.
Thanks,
Thanks,
Sam.
Tom. Thanks, Sam. Thank you all for coming. And yeah, there's a all things JavaScript channel here on the Discord, which we try to peek in on from time to time. So if you have follow-up questions or download the patches and have things, that's a place that you can ask more questions over time.
Stream will be up later today if you'd like to review it, and I'll also repost these patches that Joshua and Sam shared in the general channel, and probably the JavaScript channel too. So you won't have to dig back through this chat. Thanks for hanging out, folks. We'll be back next Wednesday, the 27th at 2 p.m. Pacific with David Zaccarelli. We'll see you then. Bye. All right. Good work, guys.
Hey.
Cool.
Hey.
Thank you both.
Yeah, that was